biomolecules. So at the first instance, if we break down the word, we can understand it as biological molecules. Now what are these biological molecules and why they are important? So सबसे पहले let's talk about the sequence. So living organisms, meaning plants and animals, consist of various organs in them. These organs in turn have tissues which are having cells. The cells have the nucleic part which is called organelles, and these organelles are basically consisting of many molecules, and these molecules in turn are composed of atoms, mainly carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. Mainly carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. Now these atoms combine in a specific manner to form molecules. This molecules itself doesn't have any life, but when they are combining in a complex but in an organized manner, they are able to produce life and also control various biological reactions which happen in our body. So these molecules which are able to control the biological reactions are basically referred as biomolecules. So biomolecules are basically lifeless molecules. They themselves doesn't have any life. But when they are combined in a specific manner, in an organized manner, they are able to produce life and also control the various biological reactions. So these molecules are referred as biomolecules. What are biomolecules? Examples: carbohydrates, amino acids. Amino acids basically the polymeric form. If we consider, they are nothing but proteins. Amino acids ka polymer are proteins. Then we have fats, which are also referred as lipids. The smaller biomolecules like vitamins. The nucleic acid, which consists of the genetic information inherited, and they are nothing but consisting of DNA, RNA. Clear? So these are the various important biomolecules which we are going to refer in this chapter, and each of the section is being discussed in very much detail. The most important part and interesting would be the first one, that is carbohydrates, with reference to the structure, the chemical reactions and various other aspects with respect to the properties of carbohydrates will be discussed. Clear? So, एक बार फिर से, living organisms meaning the plants and animals are consisting of the various organs. The organs have tissues, tissues have the cells, and cells के अंदर the nucleic part or the chloroplast can be referred as organelles, and these organelles contain the molecules which in turn is composed of various important organic atoms like carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, and they in turn are basically lifeless, but when they are combined in a complex but in an organized manner, they are able to produce life, sustain life, and they are able to control the biological reactions. So biomolecules are important for the growth and maintenance. The deficiency or absence of the required biomolecule in the body can cause various problems or side effects or diseases. Okay? So on that note, let's start with the first part, that is carbohydrates. The first thing, by looking at the word carbohydrates, we can understand in a simple manner they are carbohydrates. Carbohydrates. Hydrates refer to water molecule. Hydrate या hydration refers to water. So carbohydrates at the first instance are the compounds in which the carbon is surrounded by the water molecules. That's the reason the carbohydrates were referred by a formula CxH2OY. The carbon atom is surrounded by the water molecules, and that's why they are represented by the formula CxH2OY. But this particular formula does not fit into the carbohydrates which are actually existing. Not all carbohydrates satisfy this particular formula. There were problems with the initial definition with respect to carbohydrates. Okay? First, if we talk about the common carbohydrates ka example like glucose, sucrose, the word ending with O's are basically the carbohydrates. Glucose, sucrose, when they were broken down, it was observed that they do not yield any water molecules. There were no free water molecules which are present inside the compound. So, the earlier definition which referred that the carbon atom was surrounded by water molecule was not applicable. Correct? Secondly, there were many compounds which satisfied this formula of CxH2OY, but they were not the carbohydrates. The simplest example to this is acetic acid. Now we know that acetic acid is a carboxylic acid. If I write the molecular formula, I will be getting C2H4O2, which I can write equivalently as C2H2O twice. So it fits into this formula. But obviously it's not a carbohydrate, it's a carboxylic acid. Another problem, there were some compounds which were carbohydrates but does not satisfy this formula. There was an example of a carbohydrate, rhamnose, which had the formula C6H12O5. C6H12O5. Now, if I were to write in this particular format, I will not be able to write it. So, this compound is a carbohydrate but does not satisfy this formula. Correct? So, with all these problems, the old definition of carbohydrate was scrapped, but the name was retained. Carbohydrate name is retained now with a different meaning. And now, what is the new definition which is applicable? Let's understand. Carbohydrates with the chemical reactions were observed to be polyhydroxy aldehydes or ketones. In simple word, they are polyhydroxy aldehydes or ketones, and they contain the chiral carbon in them. That is why they were found to be optically active. And the complex carbohydrates can be broken down to give such molecules of polyhydroxy aldehydes or ketones. So the new definition of carbohydrate is carbohydrates are optically active polyhydroxy aldehydes or ketones, or the compounds which on hydrolysis, that is breaking down using water, produces these compounds of polyhydroxy aldehyde or ketone are called carbohydrates. Clear? एक बार फिर से, with reference to the old definition, it was assumed that carbohydrates have the compounds in which water molecules surrounds the carbon. But the common carbohydrates like glucose, sucrose, when they were observed chemically, they didn't have any water molecules which were free, which can be removed. Secondly, in this formula CxH2OY, there were many compounds which satisfies, but they were not the carbohydrates. Other way round, there were many carbohydrates which do not fit into this formula, but they were actually having the properties of carbohydrates. That is why we have a new definition to carbohydrates based on the chemical reactions, and they were observed to be optically active, having many OH groups and the aldehydic or the ketonic group. So they are optically active polyhydroxy aldehydes or ketones, or the compounds which can produce these compounds on hydrolysis. Lysis yani breakdown. Clear? So that's the introduction to the carbohydrates. Now let's move on to the various carbohydrates structures with their examples. Before we move on, what is carbohydrate important for? Growth and development, and the main source of energy is carbohydrate. Whenever our body requires energy, the carbohydrates break down and finally they produce the energy. They are basically the powerhouse of the body where the energy is supplied for various biological purposes. Okay? Now, let's understand the carbohydrates with reference to classification. Now, this classification of carbohydrate is done on the basis of hydrolysis. Classification based on hydrolysis. So based on hydrolysis, they are classified into three types. Monosaccharides. Now saccharide come from a Greek word saccharum, which means sugar. Carbohydrates are sweet in taste, that is why they are referred as sugars, and in Greek word saccharum they are referred as saccharide. Hence the carbohydrate ka first classification is monosaccharides. Secondly, they can also be classified as oligosaccharides. And thirdly, they are classified as polysaccharides. Now it's simple to understand. Monosaccharides are those which will not be able to hydrolyze, meaning they are the simplest unit of carbohydrates which cannot be broken down further. They are the simplest unit of carbohydrates which cannot be broken down further, because mono itself is a single unit of carbohydrate. Oligosaccharides are those which can produce many saccharides, but the range which is described here is 2 to 10. Meaning on breakdown, if they produce 2 to 10 units of the simplest one, that is monosaccharides, they will be called oligosaccharides. So oligosaccharides are those carbohydrates which on hydrolysis produces 2 to 10 units of monosaccharides. If they produce 2 units, they are called disaccharide, 3 units trisaccharide, 4 units tetrasaccharide, and so on. Next, अगर 11 या 11 से ज़्यादा होगा, then they will be simply called polysaccharides. Now polysaccharides are those carbohydrates which do not have the sweet taste. That is why, with reference to the absence of the sweetness, they are actually also referred as non-sugars. The example of polysaccharide would be starch or cellulose. Starch or cellulose, which is found in potato, maize, this doesn't have the sweet taste. That is why they are also referred as non-sugars. Okay? So 3 levels of classification we are going to understand in detail now. The first part of that is monosaccharides. Once again, monosaccharides are those carbohydrates which do not break down, or which are the simplest unit of carbohydrates, not able to hydrolyze further. Okay? Now, with reference to the new definition, what are carbohydrates? Polyhydroxy aldehydes or ketones. Now, if the carbohydrate contains an aldehyde group, it is called an aldose. If it contains a ketone group, it's called as a ketose. So, the type of monosaccharide which we are discussing over here are aldoses and ketoses. Aldoses and ketoses. The formula of these monosaccharides are of the type CXH2OY only. जब monosaccharides की बात करते हैं तो they satisfy the initial formula of CXH2OY. ठीक है? In fact, the X and Y in these cases are found to be exactly equal. मतलब it can be referred as CnH2O n times. CnH2O n times. अब simplest unit of the carbohydrate starts with minimum 3 carbon atoms. See, by the definition you can see there should be polyhydroxy, मतलब एक से ज़्यादा OH, and at least one aldehyde or a ketone group. So, since बनता है एक aldehyde या एक ketone एक कार्बन देगा, polyhydroxy मतलब minimum 2 OH. Hence, the simplest unit of carbohydrate starts with minimum 3 carbon atom. This is also very important. The simplest carbohydrate starts with 3 carbon atom. Now the formula for the aldose or ketose with 3 carbon atom, first of all, would be referred as a triose. With 4 carbon atoms, it would be called tetrose. With 5, pentose, and with 6, hexose. So when we have the aldose with 3 carbon atoms, it is combinedly called as aldotriose. Ketos with 3 carbon atom, it would be called as a ketotriose, and so on. Nomenclature clear hai? The type of the monosaccharide with an aldehyde group is called aldose, and with a ketonic group is called ketose. Minimum they will start with 3 carbon atoms, hence 3 carbon carbohydrate is called triose, 4 is called tetrose, pentose, hexose. Then if we have the aldose with 3 carbon atom, isko jodoge to aldotriose, ketotriose, aldo, keto, tetrose, and so on. Clear? Now coming to the triose. Now the simplest of the carbohydrate with 3 carbon atom and an aldehyde group, the formula would be C3H6O3. As I said, they would be having the formula CnH2O n times. So I can actually open up and write CnH2O वापस carbon जितना. Same way में tetrose would have the formula C4H8O4. This will have C5H10O5 and C6H0O6, and that's where we have the glucose. Okay, so अब structurally let's understand. Aldose में there should be an aldehyde group, and all the aldehyde groups always reside at the terminal position, which is the first position. So we have the aldehyde group as CHO. Then we have 2 carbon atoms with the OH group. So I'll just satisfy this as OH and OH. So it's a polyhydroxyaldehyde. Should start with minimum 3 carbon atoms. Correct? Now if I satisfy the valency, you get H and H2. What else do you observe with respect to the central carbon? It's a diol, okay. Chiral. The central atom, if you see, it's bonded to 4 groups, an aldehyde, H, OH, and a CH2OH, which are all different. So it is having a chiral carbon, meaning an optically active. So अब पूरा definition वापस देखो. Carbohydrates in general are optically active polyhydroxyaldehyde or ketone. Clear है? अब ketonic compound with 3 carbon अगर बनाना है तो ketone should be at what position? Middle पे ही होना चाहिए. And this second carbon ketone should be satisfied with 2 carbon having the OH. Now if I satisfy the valency, it will be H2H2. This is the only carbohydrate which is optically inactive. A very, very important question. The only optically inactive carbohydrate is the ketotriose. ठीक है, अब इसका नेम करते हैं. If I just for time being replace the OH by H, what do you observe? Acetone. Now in acetone, if I remove the H by OH, it will be a dihydroxyacetone. So this particular compound, which is optically inactive, is dihydroxy derivative of acetone, dihydroxyacetone. Clear है? समझा? अब carbohydrates के लिए one nomenclature is very important. I'll discuss here. If I look at the first compound, the central carbon being chiral, I can represent in Fischer projection, and this Fischer projection will have the CHO at the top, the CH2OH at the bottom, and the chiral carbon can have H and OH. Correct? Its mirror image would be non-superimposable, and if this is dextro, the other would be levo. Dextro is indicated by a small d, levo is indicated by a small l. And the difference in these isomers is the property towards PPL, plain polarized light. If this compound rotates the PPL to the right, it is dextrorotatory and it will be called as a D compound, small d. And on the other end, its mirror image would be levorotatory, indicated by L. Now this was small d and small l notation. In carbohydrates, we also have a capital D and capital L notation. And this is different from what we have already studied. छोटा d, छोटा l क्या होता है अभी बताया. I am now discussing capital D and capital L. Capital D or D sugars are those sugars in which the second last carbon का OH resides or is placed to the right. In the sugars, if the second last carbon ka OH is on the right, it will always be called as a capital D sugar. Now what is the significance of this notation? You will understand when we talk about the structure of glucose in depth. ठीक है, अभी के लिए capital D sugars are those sugars in which the second last carbon, which is probably bottom से first chiral carbon, उसका OH on the right will be called as a D sugar. And its mirror image, if I draw, the OH would come to the left. Then it will be a capital L sugar. And capital L is not equal to small l, nor capital D is equal to small d. Is that very clear? This DL, chota DL notation indicates its behavior towards PPL. This capital DL indicates the position of OH on the second last carbon or bottom say first chiral carbon. ठीक है?
So glucose will be an L sugar, right? Because except for that one OH,
it's a D sugar. And I have shown you the structure also. Only the third carbon का OH is on the left. Rest all are on the right. It's a D sugar. ठीक है? ये clear है यहाँ तक? So एक बार फिर से, a capital D sugar is that sugar in which the second last carbon का OH lies on the right, and there is a very important significance to this particular notation that I'll discuss later. But remember what is capital D, what is capital L, and very importantly, it is not similar to the small d and small l. A very important thing to be remembered. Okay? So now let's start with the structure. So this chiral compound in the Fischer projection could be written with a plus notation having H and OH. So it's a D sugar or L sugar? It's a D sugar. And this particular compound is named as glyceraldehyde. The simplest of the carbohydrate, that is an aldotriose, is named as glyceraldehyde. Now next structures are simple to reproduce. 4 carbon atoms में the first carbon will always be CHO. Last carbon has to be a primary alcoholic group, and बीच में the 2 carbon atoms would be secondary alcoholic group, which are going to be chiral. And the placement would be H, OH, H, OH. Now how many possible isomers could this compound have? 4.
2:2.
Correct.
Yeah.
If you have n chiral carbons, the number of optical isomers are equal to 2 raised to n. And here 2 raised to 2, it will refer to 4 isomers. So एक जिसमें the OH are on the right, second would be its mirror image, third would be switch 1 and its mirror image. ऐसे होंगे आपके 4 optical isomers. एक बार फिर से, this is first, second would be its mirror image, third would be switch one of them and take the mirror image. That will be 4 optical isomers. The name for this compound, again it's a D sugar or L sugar. The reference is always this part. इतना part आपका अगर same है तो it is a D sugar. This is what is the reference with respect to the first and the simplest carbohydrate, that is glyceraldehyde. ठीक है? And the name is erythrose. Erythrose should be remembered. Next structure, pentose के लिए, the first is CHO, last is CH2OH, and now 3 would be secondary alcoholic groups, with the placement H, OH, H, OH, H, OH. And the name is, it's a D sugar with the name ribose. 5 carbon pentose is ribose. And the last one with 6 carbon atom is glucose. So CHO, CH2OH at the bottom and the 4 chiral carbon. Now this 4 chiral carbon ka how many optical isomers would be there? 16.
One is glucose.
Yes, 2 raised to the 4 chiral carbon atom would give you 16 optical isomers. Out of them, one of the optical isomer is glucose.
What is fructose?
And नहीं ये glucose है which is an aldose. Ketose में fructose आएगा. That's different. ठीक है. In fact इसके 8 arrangements आएंगे and 8 will be their mirror images totaling to 16 isomers. So glucose के अलावा we have mannose, tellose, galactose, allose, ultrose, idose, maltose नहीं आता है. And then उसके mirror images ले लो, आपको इसके 16 optical isomers मिल जाएंगे. ठीक है. These are not to be remembered, but some of the things I'll discuss which are important with reference to the concept. Yes, entrance point of view क्या क्या important है मैं बता दूंगा. फिलहाल के लिए with 6 carbon atoms and 4 chiral carbon, the number of optical isomers are 16. One of them is glucose, and the glucose has the arrangement as H, OH. Third carbon ka OH on the left, H on the right, and then H, OH, H, OH. Once again, if you refer to the bottom part, it is a D sugar, so it will be D glucose. So it is specifically actually written as D plus glucose. Now understand this. D indicates the OH of the second last carbon on the right. Plus indicates this compound is able to rotate the PPL to the right. So it's dextrorotatory and glucose is the name. Likewise, इनका भी plus and minus रहता है, but that is something which is experimentally determined and not theoretically determined. So एक और concept यहाँ पर बहुत important है. Capital D and capital L we can directly assign just by looking at the structure. मतलब it's a theoretical concept. But dextrolevo is something which is analyzed by polarimeter. Polarimeter is a device which gives you the rotation of the PPL. If it is plus, it will be dextro. If it is minus, it is levo. So this is something which is experimentally determined. So I can determine all the structures whether it is capital D or capital L, but I can't determine whether it is छोटा D या छोटा L. ठीक है? समझ में आ गया? अब सेम वे में कीटोस का सिंपलेस्ट स्ट्रक्चर हमने देख लिया, डाइहाइड्रोक्सी एसीटोन. Up just go on adding the carbon which will be the chiral carbon or secondary OH, you will get all the other structures. So in ketos what is fixed? ऊपर वाला primary alcoholic group, second carbon ketonic, and the last one is CH2OH. This is something which is fixed. Up add one carbon and HOH, you get a tetrose, a ketotetrose. समझा? Now this ketotetrose is referred as D-erythrulose. Erythrulose. Now it's related with the aldose only. Erythrose, erythrulose. Ribose के सामने ribulose. Ribulose. And glucose के सामने we have fructose. Glucose के सामने fructose. Structure बनाना simple है. The ribulose with 5 carbon, it's a ketose पहली बात, तो it will have CH2OH, first carbon, second C double bond O, then last will be CH2OH. The remaining 2 carbon would be chiral having the arrangement H, OH, H, OH. That's D ribulose. ठीक है? And the fructose now would have CH2OH at the top, C double bond O second, CH2OH at the bottom, and the remaining 3 carbon. Now again, how many optical isomers do we have here? 8. 2 raised to 3 chiral carbon will give you 8 optical isomers, out of which one of them is fructose, which has the arrangement of once again the third carbon पे OH on the left. And then the next have HOH, HOH. It's a D sugar. And fructose rotates the PPL to the left. It is levorotatory, hence we write D minus fructose. So only for glucose and fructose you have to remember the experimental observation towards the PPL, that is dextro here and levo here. Rest you don't have to remember. समझ में आ गई? ठीक है, तो सबसे इंपॉर्टेंट ये था कि कैपिटल डी कैपिटल एल इज नॉट सेम एज छोटा डी छोटा एल, एंड दिस इज अ थियोरेटिकल कॉन्सेप्ट. छोटा डी छोटा एल इज एन एक्सपेरिमेंटल कॉन्सेप्ट. सो दैट कंप्लीट्स द मोनोसैकेराइड्स का सिंपल फॉर्मूलाज एंड द स्ट्रक्चर्स. द नेम्स आर टू बी रिमेंबर्ड. अब नाम याद रखने के लिए द अल्डोज का 4 नेम्स कुड बी रिमेंबर्ड एज गर्ग, GERG in the sequence: glyceraldehyde, erythrose, ribose and glucose. Now once you remember this, इसके सामने ये वाले 2 नाम और इसका नाम तो बहुत सिंपल है, खाली एक ही याद रखना है. और उसमें भी एक सिंपल इंपॉर्टेंट स्टेटमेंट है that it is the only carbohydrate which is optically inactive. So glyceraldehyde you remember with dihydroxyacetone, erythrose, erythrulose, ribose, ribulose and glucose के सामने fructose with the concept of plus here and minus here. Is this clear? So the second part or the second classification is oligosaccharides. By definition, they are those carbohydrates which on hydrolysis produces 2 to 10 units of monosaccharides. 2 to 10 units of monosaccharides. Based on this, they can be further classified as disaccharide, trisaccharide, tetrasaccharide and so on. But important, we are discussing only the di, tri and tetra. Now the disaccharide have the formula C12H22O11. C12H22O11. The common disaccharides are sucrose, maltose and the milk sugar which is lactose. These 3 can be remembered as small, medium, large. SML. Sucrose, maltose, lactose. So disaccharides, 3 examples, SML to be remembered. Now disaccharides are those which on hydrolysis or breakdown using water would produce no.
ATP.
Array oligo will produce 2 to 10. Now when it produces 2, it will be a disaccharide. So sucrose, maltose, lactose all on hydrolysis will be producing 2 units, and sucrose is famously giving you glucose and fructose. So sucrose on hydrolysis gives you G and F, glucose, fructose. Maltose gives you 2 units of glucose, that is glucose and glucose. Lactose gives you 1 unit of galactose and 1 unit of glucose, and it has to be remembered in a sequence. Again, there is a reason for this. So you will be remembering as galactose and glucose, not vice versa. ठीक है? So sucrose, maltose, lactose hydrolyzes to give you 2 units of monosaccharides. Now glucose and fructose we know. Let's talk about galactose, and there is an important relation. Glucose का structure एक बार फिर से, we have a CHO at the top, 4 chiral carbon and the last one CH2OH. So it's H, OH, OH, H, H, OH and H, OH. This is your glucose. Now galactose is an optical isomer of glucose in which the 4th carbon ka OH also is on the left. Matlab there will be now 2 OH groups which are lying on the left. One at the 3rd carbon jo glucose mein tha, plus one more carbon, that is 4th one ka OH on the left. So this will be OH, H, 4th carbon OH, H and the last will be H, OH. Are you clear with this? Now one thing which is very important. If you look at glucose and this is your galactose, how many chiral centers are having the configuration which is different? How many chiral carbon are having the configuration which is different? One. I'm asking you, relate glucose and galactose. Second, third, fifth. Second, third, fifth. Same hai. What is differing is only the configuration at the fourth position, right? Now those stereoisomers which are having the difference in the configuration only at one chiral center, they are called epimers. So one simple statement which is important, glucose and galactose are optical isomers, but commonly, very importantly, they are epimers. Correct? एक बार फिर से, glucose and galactose are having the configuration of the fourth chiral carbon which is different. ऐसे stereoisomers which have the difference in configuration of only one chiral center, they are called epimers. समझा? Similarly, mannose करके होता है ना. mannose में ग्लूकोज के जैसा ही स्ट्रक्चर, खाली सेकेंड कार्बन पे OH लेफ्ट में होता है, तो वो भी एपीमर हो गया. समझ में आया? एक और लिख लेता हूं चाहिए तो. mannose is again an optical isomer of glucose in which you have second carbon का OH on the left. Rest of the structure entirely is same as glucose. तो फर्क कहां पे आ गया? ये. Correct? तो glucose and mannose are what? Epimers. Now, if I just talk about mannose and galactose, there is a difference at the second and fourth. तो दो पे जब डिफरेंस होगा वो एपीमर नहीं कहलाएगा. So glucose galactose and glucose mannose are epimers, but galactose mannose are not epimers. एक फोर्थ स्ट्रक्चर भी बता देता हूं, टेलोज. टेलोज में दूसरा और चौथा दोनों कार्बन पे चेंज हो जाता है एक साथ. मतलब पहले मैंने गैलेक्टोज बोला, फोर्थ कार्बन, मैनोज बोला, सेकेंड कार्बन, टेलोज में सेकेंड और फोर्थ दोनों. तो स्ट्रक्चर समझ में आ जाना चाहिए. CHO लास्ट में, CH2OH और चार काइरल कार्बन में OH-H, OH-H, OH-H and HOH. अब गैलेक्टोज और किसका? गैलेक्टोज में इफ यू सी थर्ड एंड फोर्थ दोनों में सेम है. डिफरेंस अगेन खाली कहां पर है? सेकेंड पे. तो गैलेक्टोज एंड टेलोज आर एपीमर्स. और किसी का एपीमर? मैनोज और टेलोज, ये भी होगा क्योंकि इस जहां पर सेकेंड पे या फोर्थ पे चेंज किया है वो टेलोज के साथ एपीमर हो जाएगा. ऑब्वियसली ग्लूकोज के साथ नहीं होगा. समझा? क्लियर है? तो एपीमर्स के पेयर्स अगर पूछें, मतलब स्टेटमेंट्स याद हो जाने चाहिए. एपीमर्स सबसे इंपॉर्टेंट है अपना ग्लूकोज गैलेक्टोज. मैं शॉर्ट एब्रिविएशन लिख रहा हूं. GLU ग्लूकोज का है, GA गैलेक्टोज का है. ठीक है? उसके अलावा ग्लूकोज विथ मैनोज, देन गैलेक्टोज विथ टेलोज and mannose with टेलोज are epimers of each other. They are all optical isomers within them, but epimer is a special name given to those stereoisomers having the difference only in one chiral carbon. Clear? Yes or no? This is something very important. Okay. Moving back to this, disaccharides में we have the three examples: sucrose, maltose, lactose. Next, trisaccharide. The formula is C18H32O16, and tetra में the formula is C24H42O21. अब याद रखने का सिंपल तरीका, इफ यू लुक एट द नंबर ऑफ कार्बन, दे आर मल्टीपल्स ऑफ 2, सॉरी दे आर मल्टीपल्स ऑफ 6. डाई में 6 into 2 12, 6 into 3 18, 6 into 4 24. Die is remembered as H22. Add 10 to it, 32. Add 10 to it, 42. Oxygen is just half of hydrogen. So once you remember this formula, बाकी दो formula याद आ जाएंगे. Clear है? It's C12, C18, C24, then H 22, 32, 42, O just half of the hydrogen. ठीक है. Try में the example of the carbohydrate is raffinose, and tetra में we have the example as stachyose. Example is stachyose. Now this on hydrolysis should produce 3 units and this on hydrolysis should produce 4 units. Correct? Now generally after the disaccharides, the units are common as glucose, fructose and the remaining galactose. Glucose, fructose और जितने भी बचे galactose. यानी raffinose का hydrolysis क्या देगा? Glucose, fructose, galactose. Stachyose, glucose, fructose, galactose. अब अगर पेंटा भी पूछ लिया तो glucose, fructose and 3 units of galactose and so on. Clear? ठीक है? So because when we look at the structure of lactose, the first unit galactose and the second unit is glucose, from which there is a loss of water and there is a glycosidic linkage which is formed. So the linkage is formed from first unit of galactose and the second unit of glucose. तो जब structure बताऊंगा ये चीज justify करूंगा. अभी के लिए याद रखना वही order में है, इसलिए reverse नहीं करना है. ठीक है? And the third part is polysaccharides. Polysaccharides are those which will give you many units of monosaccharides, minimum 11 and 11 onwards. ठीक है? The example of polysaccharides which are also named as non-sugars are starch, cellulose, gum. These are all examples of polysaccharides. Next, a small concept but very important. Reducing and non-reducing sugars. Now the sugars can also be classified depending on the test which they are able to pass. There are 2 tests for carbohydrates, which is Rowlands and Felings test. Now this will be studied in detail when we talk about the carbonyl compounds. As of now, Rowlands and Felings test is a test for the aldehyde group, that is a CHO, or a ketone, but specifically only which has the alpha OH, alpha hydroxy. So the compounds which have the aldehyde or the ketone with alpha hydroxy group passes the Rowlands or Felings test, and those sugars which pass this test are called reducing sugars. Now if you look at the monosaccharides, the first one was glyceraldehyde CHO with CHOH and then CH2OH. It contains an aldehyde group. ठीक है. Next में we have CH2OH, C double bond O, CH2OH. So we have a ketone, and to the alpha carbon we have the OH. It's an alpha hydroxy ketone. मतलब सारे monosaccharides have the aldehyde or the alpha hydroxy ketone, so they will be passing the Rowlands or Felings test. Hence all monosaccharides, whether it is an aldose or ketose, will be called as reducing sugars. Secondly, when I talk about oligosaccharides, only one of them is non-reducing, and that is sucrose. That is sucrose. Why? Because when we talk about sucrose ka structure, it will be related to the glucose and fructose ka units. So a disaccharide is basically formed when the 2 monosaccharides loses a water, गिविंग यू दिस, करेक्ट। इसका भी हम स्ट्रक्चर देखने वाले हैं। नाउ व्हेन वी डिस्कस द स्ट्रक्चर, द ग्लूकोज एंड फ्रक्टोज का aldehyde or the ketonic group are involved in the bond formation. If they are involved in the bond formation, they will not be able to replicate this functional group on breakdown, and that is the reason they will not be able to pass the test. But बाकी सारे पॉली या फिर ओलिगोसैकेराइड्स हम डिस्कस करेंगे, उनमें there will be one of the functional group which will be free, which we can obtain on hydrolysis. But sucrose is one such example where the free aldehydic or the ketonic group is not reproduced. Hence, it's a non-reducing sugar. In fact, it is the only example of a non-reducing sugar. तो simple way में याद क्या रखना है? All carbohydrates are reducing except sucrose. Except sucrose. Is that clear?